Okay, still? All right. This is getting crazier and crazier. Central cord syndrome. Small lesion of the central cord. What you're going to end up losing is pain and temperature. You go, It's over here. This loss is a high cord problem. We're losing these areas. Why? Explain to me why. With what they're showing you here, what's going on?
The crossing over.
The what?
Crossing over.
That's right. Because these signals are crossing and you're knocking them out at the point of crossing over. Oh, you're not losing this, by the way. Oh.
Is there a particular reason why it's just like a half of the arm?
They're just showing you one particular
Okay, there
ear
can
tone.
be.
Once again, we could move this damage up and down, and we could lose lots of other stuff. Yeah. You know, once again, showing you this, I think what he's attempted to do is show you pretty obvious differences.
So let's walk in the crossing over of the
Anterolateral.
system.
Yep. So what you're doing is you're damaging it somehow. We'll talk about this in just a second. Central cord. Central cord is, once again, another pretty strange thing. Because essentially we have high central cord damage in here. We lose motor everywhere. We're knocking out all these motor tracts. We lose the anterolateral pain and temperature. We lose vibration and position from the posterior cord, but you still maintain the genitals. You go, whoa, wait a minute. What is going on here? What's happening? How can that be? How can that be? That's a really good question. Now let's go back to thinking about things like autonomic system inputs. Let's think about that. Parasympathetic inputs. Oh, darn. You remember where they come from? To the genitals? The sacral cord. Okay. Okay. What about the sympathetic inputs? Thoracic cord. Oh. This damage is occurring fairly high. Okay, because you're knocking everything out up here, right? You're not knocking out the sympathetic ganglia. You're not knocking out the parasympathetic inputs. You're knocking out all of the sensory stuff. All of some of your, I'm starting to have a lot of throat issue right now, excuse me. You're still getting inputs to the sympathetic chain. You're still getting some signaling, not a lot, down to the sacral cord. So you still have some sympathetic and parasympathetic inputs. But you have nothing to the body. The rest of the body is done. Spinal cord contusion. What's a contusion? So we have some form of bruising. Syringomyelia and various cord tumors. with syringomyelia, we end up getting a buildup of pressure, and we start to actually get the equivalent. I don't want to. It's not like an abscess, but it can be similar. So you got a buildup of fluid, and you have a loss of motor and somatic sensation. Various cord tumors, astrocytomas, ependymiomas, hemangioblastoma. So obviously, these tumors are affecting the central region of the cord and spreading out from there. Ependymiomas have to affect the central canal. Typically, you're going to see that's probably secondary to a tumor in the brain. Posterior cord syndrome. This is an easy one, all right? Posterior cord syndrome, we lose vibration, position, okay? Once again, we're talking a fairly high lesion here. This is more likely due to trauma than anything else. Once again, hit in the back here somehow, and you lose those position and, yeah.
When you say position, is that like if they were to close their eyes and
Yes,
close their
you
eyes?
couldn't do that.
Okay.
Okay? Position sense is the ability to know where your body parts are. And then anterior cord syndrome tends to knock out the anterolateral and motor pathways. So, a good thing for you to work with is this simplified drawing of the cord with the posterior column, the anterolateral, and the prime motor pathways going to your lower body. Another big issue. I don't know what else to say about this. Other than this is going to require some reading on your part. You have to really read what goes on with this. So, control of urinary function. Yes. Control of peeing. This is one of the big issues. Urethral bladder afferents, bringing signals in, efferents, taking signals out. These are sacral spinal nerve issues. Pretty much everything else is going to go on in the brain. Signals are going to be coming up the column to the brain and coming on out and contracting the bladder, relaxing the bladder, opening sphincters, etc. Yeah. Where to start? The Pontine Micturition Center. Micturition is the technical term for urination. All right? So if urination is not technical, then peeing is even less technical. All right? Yeah. This center is getting signals that essentially says the bladder is becoming distended. As the bladder becomes distended, there are a couple of things you're going to want to do.
Distended meaning full or empty or contracted?
Oh, distended. Yes. Filling. Yes. Sorry. Typically what happens as your bladder starts to distend is that you have control over half of your urethral output, so to speak. So with your urethra, you have definitely not drawn the size. I have that picture of this. Here. Ignore everything it's saying. I just want the bladder and urethra. So this is a female. So we have the bladder here. As it fills, it becomes distended. You have muscles in here that are going to pull it together to empty it. But then we have the urethra, and we've got the pelvic diaphragm here, and we have a sphincter in here. The pelvic diaphragm, really important structure in both males and females. It tends to be more important in females. Males have different issues with urinating than females do. So that as you get ready to urinate, this sphincter is going to relax. You are going to relax your pelvic diaphragm. You are going to contract your bladder, and you will then pee. So that's the major issue for females. With males, urination is frequently more under the control of the prostate gland. I don't know if you remember, but so you know the vas deferens is coming out through the prostate, and it's going to tie into the urethra. And as a result, in a male, the prostate controls whether you can urinate or ejaculate. So males have the prostate to help with controlling urination. And additionally, they have about an extra 15 centimeters of urethra. You know, it's just much longer in a male than in a female. I mean, a female, the typical, talk about not drawn to scale, okay? This distance from the bladder to the outside in typical female is 30 to 40 millimeters. It's not very, it's this far, okay? I mean, in a guy, there's a little more internally, and then you have the penis. And what you have to do is measure an erect penis to the bladder, and that's the distance in a guy. So there is more distance involved with relaxing the whole urethra. So let's get back to this whole micturition center area. Yes?
Which of the pelvic diaphragm and the sphincter are under voluntary control?
The pelvic diaphragm, the sphincters are not.
Okay.
You can control no sphincters. Well, oh, I take that back. There's the anal sphincter, the external anal sphincter you can control. You have some control over the pelvic diaphragm. Now the pelvic diaphragm for a woman is about yay big, and through the pelvic diaphragm comes the anus, the urethra, and the vagina, the whole vaginal vault area. So women sometimes will have issues with aging or after having babies with urination. And the problem is, you know, you dribble. That's, you know, that's the way it goes. Older guys also dribble. Dribbling is a fact of life, especially in basketball. And I find many women know this fact. Kegel exercises. Kegels are exercises for the pelvic diaphragm.